Hello everyone, Anthony here once again with episode 13 where we create a complete production ready blockchain in Golang. And before we continue, I did some off-stream coding yesterday evening. Let's open up txpool. I basically rewrote the whole txpool, the whole mempool, because it had some issues. I'm not going to cover this completely in depth, but right now I have basically two pools. Basically the all pool, which is a lookup, all transactions that come in, every transaction we've seen. And then we have a pending pool, which is basically the pool we're going to use to insert in a block. And then we can clear the pending pool, but we keep the all pool so we can keep track of transactions we already seen. I also removed the tx sorter because we now have a tx sorted map, which I implemented. It's basically just a structure with a lock, of course, and a lookup, which is the map, and a txx, which is basically a list. And that list, what is going on? And a list is a wrapper around the slice to do some convenience methods and so on and so on. That's what I did. That's how it's popping. So let's continue where we left off. And it's basically we created a block and we need to distribute that block into the network so all of our other nodes where we are connected to can sync. But first, let's see if everything is working fine. New block. Yeah. Okay, cool. Encoding. So to be able to distribute this block over the network, any kind of transport, we need to encode it. And for now, we are using a hop encoding, which we use for bootstrapping the project. Later on, we can move to gRPC, proto buffers, whatever we want. Yeah, let's create an hop block encoder. Takes in a writer, new hop block encoder with a writer, hop block encoder, and then we say hop block like this, put in the writer and call it a day. Then we're gonna call this function hop block encoder encode and codes block error, and we say new encoder the writer encode or block. And we're gonna do the same thing for our decoder. Decoder, it will take a reader. And guys, don't forget, if you have any questions, please feel free to ask them in the comments or DM me or whatever. Happy to resolve them. Decoder. And probably next week, when I have more time, I'm gonna live stream instead of recording. That would be amazing. Decoder, let's get back on track. Decoder. Wait, this is deck R decode B and call it a day. So one thing I was noticing is basically this GOP register thing. That's going to be an issue because I will explain later. Let's first create a test real quick. Test decode encode block T testing T b random block, and st a pref hash, a height. Let's give it a height. Let's give it types hash empty. Let's create a buffer. Bytes. Assert nil t b.encode, of course, and then we say new gob block, and that's an encoder with the buffer. So we encode this block in the buffer, and then we need to have something like b decode. It's going to be a new block, and then we say the same thing, but we're going to do b decode, and we're going to decode this. We need a new decoder. What the hell is this? Did we have this function? New hop block. Yeah. What's going on? What's going on? What the hell is this? Come on. Decode, what the hell? Yeah, decoder, yeah. Okay, cool. And then we're gonna assert equal tb decode, make test and see if it works. All right, that's working. And only just one thing that I'm concerned about is this elliptic. So basically, GOP can decode and encode interfaces, which is this elliptic P256 is. And right now we have no issues because I think our test is running this TX stuff, and it will call register this thing. But what if we don't have registered that in production? So maybe we can do an init function like this, and put it in here. For the people that don't know, init is getting called each time, or I think init is getting called the first time you basically initialize this package. So if you call something from encoding, it will call init, and we are good. So we don't need to do this here. You see, perfectly working. And now I want to test if it's working there also. Yeah, we are good. Server, little coffee. Need to keep sharp, need to stay sharp. So now we have something broadcast block. So we can do, let's make a buffer. Let's encode this. Is it core? Buff. Turn the errors. And let's make the message new message type block, and we do the buff bytes of that block. And then we need to broadcast this message, broadcast rather, this message and bytes. And then we need to actually broadcast this block. And where are we going to do this? Create block. We do all our logic, and then we just say go as broadcast block with the block. Oh, we're still running. Make it run. Let's see, please. Okay. That's nasty. It's probably this broadcast block. Yeah. Broadcast block. Troubles. Big troubles. Is it incrementing? I have some small tinkling potential issues that comes up to my mind. And my stomach is growling. I'm hungry. Wait, how can we... So, broadcast block. I think there is no issue with this function. The problem is going to be where we receive this thing. But we don't receive it anywhere, so I have no clue what's going on. You know what I think? Damn, that I catch this so fucking easy. That's insane. So, RPC. So basically, this is not working. And I mentioned this in the episode where we're creating this protocol. I mentioned this. I say this is something like an enum, and normally you just place this below it and it increments. And I was saying, I'm not really sure that this is working with bytes. Because I'm 100% sure it's working with ints. So yeah, you see, man, this is nasty. I thought it should work. It would work, but it isn't. So let's open up. Where am I? Man, this is getting so confused and so big. Yeah, let's do this like case corpun block. Return as process block. We don't have process block, but we're gonna make this. FMT, println. We're gonna do for now printf v. Come on, Visual Studio, please. B, like this, and return no. Actually, okay. Let's see what's going on. Nothing. But wait, we're not calling this, right? Ah, stupid mistakes. So let's see what's going on right now. Invalid message header too. Okay, that's good. That's good. Where do we call this invalid message header? Probably here. No. Invalid message. Is it in RPC then? Yeah. Yeah. Okay, cool. So we need to decode it, right? This is where the decoding happens. So we say if the header is a message type tx, we do this stuff case message type block. We're gonna say block is new core block, and we need to decode this thing. Block decode core new block decoder with bytes new reader, and it's gonna be MSG data. And if there is an error, we return. Wait, what does it return? No error. Otherwise, we return a decoded message from RPC from, and data is going to be our block. Does it make sense? And we return no error and call it a day. Make run and see what's going on. All right, so we're getting a new block. Wait, because I'm a little bit confused, to be honest. Oh, no, it's because we server process block. Process block. Let's open a blockchain real quick, because I'm not sure what it checks and what it don't checks. So if you want to add a block, we validate the block, and then we just add a validator. We check if we have it. We check if the okay. We can. I think for now we can do chain add block b. Return this just for the sake. Yeah, I think we can do that. Make run and see what's going on. Wait, because it's so hard to follow up, because we are logging all these transactions, right? So adding transactions to the mempool. Let's quickly just do this. Make run to see what's going on. So remote 0 is getting a new block. Yeah, exactly. So yeah, what's going on is basically main. So previous episode we connected, we created some couple of more remote nodes, and we connected our local node with A, and A with local. And A is sending us these transactions, and we're creating a block, and we broadcast a block, but we only have A in our peer list. So to make sure that we gossip this block to everybody in the network, we need to say in process block, we need to make sure that there is no error, I guess, as chain add block, the block this, we can return error, or we do, should we? Then we could say something like as broadcast block, which is basically this thing, and return null. So what's going to happen is that basically we are going to get the same block, and maybe we should fix that we don't broadcast back to the peer we are receiving from. But for now, I don't think it's an issue, because we will see that the block already exists and we won't add it. But it could be a nice network optimization, because it's a wasted bandwidth. So this should work actually. Make run. Yeah. Change, yeah. So you see, it already contains, but it's okay. And everybody is nice in sync, right? You see the local, the remote, and the remote 2, and the remote 0. Everybody is at height 5. And that's what I meant by this local or getting the same error. Or getting the error that chain already contains block 6, but it doesn't matter. We can fix it later on. So let us quickly recap actually. So we have 0, 8, 8, 8, and local 8, 1, 2, 3, yeah. Yeah, everybody is synced. Everybody is synced. So, nice. Nice. The question is, what do we log and what do we don't log, because it's going to get messy, to be honest. Doesn't matter. So, our validator is making a block, and only our validator is responsible for that. Then he is broadcasting this block to his peers, and these peers are validating that block, and if everything is fine, they rebroadcast it to the network, and that's some kind of a butterfly effect. The gossip is doing its thing. So everybody is synced. And let's see, it's 23 minutes, okay. So the problem rather is, and I can demonstrate this to be honest, is let's make sure we disable this logging, because otherwise it's so hard to follow up. What we're gonna do is, right now everybody is in sync, and the reason for that is because everybody's booting up at the same time, so nobody is behind and nobody is ahead, and everything is just perfect equilibrium, perfect harmony. But what if we do something like go func as late server, make server, need a fucking transport, or late remote is going to be tr late and tr late. An idea. Wait, what's going on? tr. What the hell's going on? I'm confused. Like this should work, and then what do we need? The tr late itself and a private key, which will be null. Well, what is this? Why? Oh. And then we say go late server start. But first we say time sleep 5 times second, okay? So what's going on? We're creating another transport, we're creating another server, another remote node. We're gonna sleep for 5 seconds and then we're gonna boot this thing up. So what's going on is that, wait, I need to make sure this is block time, right? So let's say after 7 seconds, what's going on is, what's going to happen is all our other nodes are going to be in perfect harmony. They're going to be perfect synced, but this TR late, this late guy at the party, you know, there's always somebody that comes up late and he is going to miss a couple of blocks, 1 block actually. And he's not going to get synced because it won't, his blockchain won't allow other blocks to come in because they are too high. But first, to make this work, we need to connect this TR late with something else. Let's say, wait, so it's gonna, let's connect TR remote C with him, okay? And let's hope that this works. Make run. Late remote. Holy he's getting blocks. Is he then? Okay, this guy is insane. Oh yeah, that's, I'm an idiot. It's probably the messages are coming in. Can you imagine? I'm gonna explain what's going to happen. It's actually it's so amazing that it actually worked, but it's causing issues. So make run. Let's see if it's. Damn it! This guy. Oh yeah, no. So see, now it's working. So our late remote is getting, thanks to the gossip, is getting the blocks, but the problem is that the block is too high because he's late at the party, right? So, and all the other nodes are perfectly in sync, and you see it's working perfectly how it should be. The only thing is like error block too high. I really want to print out the high, to be honest, too high. And I'm getting allergic. Wait, where do we do this? Block too high. Too high. It's probably in server then. Does given high too high? Where do we? Too high. Validated, of course. Damn. invalidator. Yes, here it is. Block is too high. Let's say something like this. D. B. Height. And I will explain why it worked, why our late guy was synced in the first time. This first new block is basically the genesis, so no worries, it's too high. Height 2 and E. Okay, let's do one more thing. Block blah 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 too high. Current height. It's Veep and BC height, I guess. Yeah, I know that this is way too long, but it is what it is. We are not Ruby on Rails. We are not the Rubyists. It needs to be perfect 80. Man, it needs to be perfect 80, whatever, 80 characters. It can be max 80 characters wide. But did you see our screens lately? Because otherwise you can't see. Did you see our screens? People are sitting with 4 fucking monitors at their desk. And we need to stay within 80 column range. What the hell? Please, this is 2022. What the fuck are you talking about? So yeah, I was making this cleaner. Late remotes, getting Genesis. Okay, with height 2 is too high, current height 0. Yes, he's at Genesis and the blockchain is at height 3 and now he's complaining it's good. All fancy, nice error logging. We are set. Yeah. 33 minutes. I think this I'm going to wrap it up for this episode because the next episode, what we're gonna do is making sure that blocks that come late to the party, like our late guy here, this TR late, basically needs to sync. And if he's out of sync, he needs to send messages. Thanks to our protocol, he can send a message. And let me quickly show this. So we have a message type TX type block, but we also gonna have like a message message type get blocks. Message type is gonna be, for example, 03. Yeah. So you can send a message for example, each 10 seconds or TR late. Basically, everybody in the network is gonna send this message type get blocks to their nodes, and everybody is going to send blocks to this guy, and then he can basically add these blocks and keep asking until he's out of sync. Maybe we can actually make it. He doesn't need to do it every interval. He can basically check in the blockchain or in the server. Can check, for example, he can check what's the difference in height. And let's say the difference is he's 10 blocks behind. He can just ask for that 10 blocks and he's Gucci, right? That's what we're gonna do in the next episode. Very important, very, very important. And don't forget to watch the previous episode, especially the first 5 minutes, because there we're discussing the purpose. What's the purpose of this chain is going to be? Is it going to be a general purpose chain with the Move compiler, Move virtual machine rather, or is it going to be a decentralized order book for trading all the things So please put something in the comments, very important, because then we can swap out to this, because we are almost done with the default blockchain shenanigans. It's almost complete. Yeah, it's almost complete. Just a couple things. So we are almost there. As usual, thanks for watching, everybody. If you like this video, if you like this concept, if you like this project, please give me a thumbs up. And don't forget to subscribe to the channel. I really, really appreciate this. Thanks, and see you in the next episode. Bye-bye.